on and we have ignition. All right, today I'm going to start with a different topic, and I could cheat if I wanted to, and I did last semester because last semester I was suffering from the stroke, and I was up there, and I posted a bunch of videos from when I did a workshop at MFI on MATLAB, and I just had the students watch those. I reopened those up this morning to where you could watch those or I'm going to cover the same material in the lectures here. So there's actually going to be 2 recordings that cover the exact same material there. The ones from the MFI workshop might be a little bit clearer because I was very healthy when I did those, and I didn't have my I refer to this as the brain damage. Most Malaysians get upset when I say that I have brain damage, but that's what a stroke is. Literally, it's parts of your brain have died off. So it is brain damage, even though it doesn't affect my thinking ability. It does make me crazy, but sometimes my language processing gets confused there. So I have to keep that in mind. But the slides are up for the subject right there. If you go to there, and this in your VLE should look the same as this, although, okay, here we go. The book that I'm using, it's not open. The book is not, well, we will fix that right now. Hopefully the internet's fine well enough. Let me get the book uploaded real quick. Well, maybe I can get the book uploaded. Right there. The slides are right here that I'm going to go through. The book, hopefully I can get uploaded here before the end of class. If not, someone come up with a thumb drive and I'll give you a copy of the book that I'm using for this discussion out there. Turn editing on. I thought it's still doing its thing. So, okay. Toward the bottom of the screen, you'll see MATLAB video session 1, 2, 3, 4, 5, 6, and 7. That's the entire course as I did it with MFI. I'm going to be going through the same slides and the same discussion here. So you don't necessarily have to watch these videos from the MFI presentation, but if you want to watch them and instead of watching the recordings of this lecture, it's fine. It's the same material. And as I said earlier, those might be a little bit more coherent because those were done in at a time before I'd had my stroke, and my energy level was good, and I was But they're also some of them are 2 hours long. Because it was done as part of an 8-hour workshop. Oh, okay. So, with that said, before I get started, let me talk a little bit about somewhere in there. There's a link on the VLE or the course website to a program called Octave. Now, Octave is a shareware version of MATLAB. It's free. You can download it. You can install it on your laptops. You can install it on your home computers. There's no charge for it. And everything that I'm doing in MATLAB, you could do in Octave as well, right there. So you don't need MATLAB. If you try to purchase a version of MATLAB for your laptop, it's probably going to be in the 10K plus RM range. It's very expensive. MATLAB is extremely expensive. I won't talk about the pirated versions that are out there because it's totally illegal. Although, if you were to look at what I'm running, you'll probably see that it's probably out there. UniKL has only purchased so many licenses for MATLAB. That's why we have to do the class upstairs. MATLAB is not on these computers. that there. I've tried talking them into putting octave on these so we didn't have to move, but that doesn't necessarily work. So I'm going to go back and forth between octave and MATLAB right there. So I used octave when I was in the U.S. to teach this particular material, simply because students didn't didn't use the Thailand Street software. I don't know if is that a correct term, and everyone knows what I mean when I say Thailand Street software. That's there, but they could buy the student version of MATLAB at the bookstore for like 100 USD or 80 USD. So it wasn't expensive. They didn't have to buy the full version. But as far as I know, there's no place to buy academic software here on UniKL. So you're either buying the full version, which is extremely cost prohibitive, or you're using pirated, or you're using Octave. And Octave is probably the preferred way to go, simply because plus Octave's a little smaller. It doesn't take up as much resources as MATLAB. That's fair. So okay, let me just kind of jump in. I kind of started this topic, but let me just kind of go through the slides here. These slides are already up on the website, so the book is not. Let me see if I can get the book up. Well, whatever reason. All right, the book I'll have to get up later, okay? Because the internet is just too slow in this room, right there. So, all right. And there's also a link on here for Octave, where you can download that and install it. So, okay. Right here, and slideshow. Let me just kind of jump through here. And again, this is from a presentation that I did about a year ago, a little over a year ago at MFI, but the same material actually, the workshop actually came from teaching in the class, and then since I put this up there. All right, this is what the default window for MATLAB looks like right there. And we've got 3 different major parts of this right here. Well, actually 4 if we count the top ribbon. On the left side, on the top, we've got, this is the current directory, and all right, now it's not working, so that's there. It's kind of funny because the other day it worked fine, so evidently it might depend on the slides. That's there. All right, I'm just going to use the pointer right there. Yeah, maybe it's got to do a new driver, but right there. All right. Yeah, it's off that there. It may be the slides. If I let me try one thing real quick. I'm trying to resave it under the new format to see whether or not that's it. Come on in. That's there. I haven't really gotten fully started yet. That's it. Nope, that didn't do it. Okay, so evidently my pen doesn't work today. Right there. So, all right, going back to our default MATLAB desktop, we've got the standard ribbon bar across the top. We've got our directory structure here, right there. And we'll talk a little bit about that later on, where we can create new, so this looks a lot like the Windows File Explorer right there. Here we've got our command history, and this is kind of like our recorder of all the commands. And this is our command window. Now, later on, probably on Monday, we'll start talking about M files and how we write programs right there. Now, the way, you know, this is, again, right here. This is a little bit different. Again, this all depends. Here I don't have the command window shown. I've got the workspace. You know, again, it depends how you set it up. You can have different windows that there. This particular slide right here is actually, looks like it's from an older version of MATLAB right there. This is MATLAB 2015. I don't know what's in the lab up there. It might be 2012, it might be 2014, it might be 2017. I'm running 2015 right there. So that happens to be a version that I've got that runs on my laptop cleanly, so that's what I use right there. The other program that I mentioned a few minutes ago, and I'm going to, I've already brought it up. And this is Octave. Again, you can see it looks very similar. You know, there's the ribbon bar across the top. It's a little bit different. Here's my, and I broke it right there. So evidently I did something I didn't like. But here's our, let's open it again, right here. Octave, and it's the GUID right there. Again, we've got that there. Here's our file browser. Here's our workspace right here. Here's our command history right there. In this particular case, I've got 5 windows instead of 4 windows right there. But it's the same basic type format. And as I said, I'm going to go back and forth between Octave and MATLAB. They're very, very similar programs in the way they function. One costs a fortune to buy, the other one's free. So that's there. So Octave is free. Download that from the internet and install it. But the major difference, when I say it's free and it does the same thing, it doesn't have the toolboxes right there. We don't have the toolboxes. We won't use the toolboxes in this class. You know, I'll talk a little bit about the toolboxes toward the end, but you don't have access to some of the toolboxes out there. So, all right, going back to my slides right here. Right there. So here's a command window. And this basically is, you know, an example of this, and we'll talk about this. We're going to set X as a row vector right there. It's going to go from 0 to 8, and it's got increments of 0.02. So it's going to be a very large array right there, or a vector. And we're going to set y equal to 5 times sine of x right there. And then we're going to plot x and y. It's that simple. So in other words, I can come up here to Octave and I can say x is equal to, and if I can do that, and I'm going to just kind of make sure I do the syntax right, bracket 0.0 colon 0.02 colon 8. And if I put the semicolon at the end, that suppresses that. Now, for right now, I'm going to take the semicolon off, and you can see that it shows that it created 72 values, or more than that, 401 values right there. And right there, if I hit the up arrow, I get the same command back right there. And I can put the semicolon, and it suppresses that right there. So most of the time you put the semicolon at the end of the line just simply because you don't want to see that 401 values, 402 values pop up right there. And now if I want to say that I want to plot that, I can say y is equal to the sign of X right there. And I got to put the equal sign in there, right there. And that's a function of my hand not working right there. So now, so if I type Y in, you can see all the values of Y there. Or I could plot X comma Y right there. And as I recall, and this is having problems with Windows 10, so I think I'm going to go back to MATLAB right there. I have not tested it thoroughly with Windows 10 right there. And there's probably an update right there. Actually, it's not necessarily Windows 10. 2 days ago, or yeah, because they wanted to do the update when I left on Monday. As you recall, my computer wanted to install the creators update, so it may have broke something here. That's there. So let me just close this and let me go back to MATLAB. Again, do the same thing. X is equal to from 0.02 on 8 right there. Right there. Oh, that's good. So it gave me an error. It actually, this particular time, it asked me, did you mean that there? It doesn't always do that there. So Y is equal to sine X right there. And plot X comma Y right there. And you can see that we got a really quick, nice, easy plot. And I think you can see the beauty of MATLAB versus C programming. You wouldn't want to write the code to do a graphical plot of X and Y. And you could do the same thing with Excel, actually. That there. And, that there. But this is easier. Right there. So, if you've got data. And again, this could be a very complex. I could do right here, plot 3 times X right there. And again, I've now changed my plot very easily. So I can play around with that function on the right-hand side. And that's it. So this is kind of the introduction of where we're looking at this right here. But this is the default MATLAB. I don't want to talk about the plot function yet. We'll talk about the plot function in more detail later. But just kind of the introduction to what the MATLAB desktop looks like, and kind of a quick example here. Now, in this particular case here, if we look at the MATLAB here we don't show the command window. We'll show the workspace. I've got 2 variables right there, X and Y, in my workspace right there. And I can, that's details. There's a preferences you can lay out right here. It says that it's workspace command history doc right here. See, now I can put the command history. I can move it over to here if I wanted to. So I can manipulate my desktop to however I want. So now this shows me all the commands. If I want to redo a command, I just have to double click it over here and it'll pop it up right there. And also, as I said, I can come over here in the command window and I can use the up arrow right there and go through my various. And for those of, I should say those of us, none of you in this room, I'm the only one in this room, remembers DOS. DOS used to work that way, where you can use the up arrow to go back to things in the command, history right there. So, okay. Right there. Entering commands. that retains your previous, up there, the up arrow, I just talked about that there. Press once, you see the previous on. Using the down arrow to scroll forward. You can use the backspace and the delete key and the left and right arrows to change the command. I just did that with the sign X. I changed it to sign 3X, and I just used the left arrow to go back and change that command. So it's fairly straightforward right there. Press the enter key to execute the command. And again, on Monday, the plan is to meet up in the lab and for you to practice with this right there. So here's some examples. Now, in these examples, if I type a formula, it's just going to solve that, just like a calculator. And a lot of people will use MATLAB or Octave as an El Cheapo calculator on their desktop, right there. I mean, it takes up a lot of memory, and unless you've got at least 8 gig of RAM in your computer, you probably wouldn't want to use MATLAB and Word at the same time, and Chrome or Firefox or whatever web browser, because it is that there. Matter of fact, if I pull up Control-Alt-Delete and I pull up the Task Manager, right there, and it's thinking right here. It should, here's what I'm looking for. As you look at it, MATLAB uses more memory than any other program running currently. Followed shortly thereafter by the the Camtasia, which is recording my lecture. So you would expect that since it's recording real live video and audio that it's going to take a lot. But MATLAB actually uses more than any other program running right there. So it just, I'm just lucky I've got a lot of memory up there. If I tried doing this with with only 4 gig of RAM in my system and I run MATLAB in the recorder, I wouldn't have enough memory. Right there, I would be that there. I happen to have about 16 gig in this computer, so it's more than enough to run MATLAB and the recorder. But these computers, I think, only have 4 gig. So if this is using 38% of memory right now, and you only had 4 gig, that means that 38% is over 4 gig right there, 16. So I'd be out of memory, which, if I'm out of memory, that means that I'm going to be using hard drive space as memory cache out there, which really, really slow. So one of the problems with MATLAB is that it is a memory hog. That whole discussion gets back to the fact that MATLAB eats up a lot of memory. And I'm not doing anything with MATLAB yet. I mean, the only thing I've got in there is two 400 element arrays. That's it. Nothing else in there. I haven't started doing any fast Fourier transforms. I haven't started doing any digital filterings. I haven't started interfacing to any hardware and trying to control A to Ds and D to As. I'm not talking to any robots. All I'm doing is just, that there is I've got 800 floating point numbers in memory, and that's it. And I'm using half a gig of RAM right there. So, okay. Just go through some of these examples here. If I just put in 8 divided by 10, it just gives me the answer. Now, if I say S is equal to 5 times 40, and I don't put the semicolon on there, it tells me the answer right there. Also, it's set up over here another variable in memory called S right there, and it assigns its value of 200. Answer is still there from the previous one, because when I didn't say S is, now if I say S is equal to 5 times 100, and I put a semicolon in there, and I got to put my equal sign there, right there, and my typing is that there. So now when I put the semicolon in there, it suppresses typing the answer right. So that there, but it changed it over here in the workspace. Now keep in mind that you don't have to have the workspace displayed. You know, you go to layout here, and I can turn off the workspace, right? Or I can turn it back on. I typically like to see the workspace. I'm not really that crazy about having the command window up there, but that there, it's just, that's the default configuration. You can well see that the fact is that because my configuration was different than the default for the slides that but you've got all, you can display the shortcuts tab, you take the tool strip away, and unfortunately once you take the tool strip away, you have to come back here and right click it to restore it, that there. I would not recommend taking the tool strip away because that's where you got that there. So, okay, that's there. Where was I in the slides? Right here. Okay, and this is just a few more examples right there. Now, if I just type S right here, it just shows what the value of S is. If I type and S gives me the last calculation right here. So right there. So that's basically how you could do fairly quick. We can call functions. Y is equal to 3 times the sine of 1. Now 1 happens to be, whenever we use sine, it has to be in radian mode, right there. So that's not 1 degree, that's 1 radian, or 57 degrees roughly, right there. I think that's right. My brain is right there. So again, I should also note here that it says, if you want more information, go to page 8 and 9. That's in the textbook that I'll make available later, right there. So the textbook that these slides came from, these page numbers refer back to that there. And that's this book right here. So we got the announcement. Everybody ignore the announcement. So if you go back here to what is it, 8 or 9? It gives more detail on the order of precedence. And again, the order of precedence is the same as C, so I'm not going to go through all that stuff. And again, he's got more examples right there in the book, right there. So now he's got some questions right here where he says use MATLAB to complete the following expression right there, for example. So I'm going to cheat here a little bit. And for example, if I want to do this first one, I'm going to do 6 times 10 divided by 13 plus 18 divided by 5 times 7, right there, plus 5 times 9 squared, for example. And that's how you would enter that right in that there. And if I had a final exam for this course, I would probably put that as one of the exam questions right there. So again, the second one's a little more interesting because we got exponentials, but 6 times 35 raised to 1 divided by 4 right there, plus 14 raised to 0.35. And again, we got to get the same answer. So it's just simply a matter of, now, is this easier to calculate with MATLAB than it is with a handheld calculator? Probably, because if you make a mistake, you can see the keystrokes right there. Obviously, if I had take-home tests and other courses, I would tell people to calculate with MATLAB. That way they can cut and paste their work into the quizzes. But if you're writing, publishing papers and things like that, it's there. So getting back to the slides right there is that, so again, right here. Here we get into the symbols right there. Again, these are the same as C, so I don't have to spend much time talking about it. This is the order. Anything in parentheses is first, and explanations, multiplication, division, and addition, subtraction. Exactly the same as C, right there. And as I said earlier, if I covered C first, and I covered it in detail, MATLAB is very quick. Right there. And again, let's just get some more examples. And I did one a few minutes ago right there. The assignment operator, that's an important one right there. And that just simply creates a variable in MATLAB and assigns it a value. We don't have to define variables in MATLAB right there. They're done automatically as we need them right there. So MATLAB doesn't have any variable definition. And when we start writing programs in MATLAB, they're not programs that are compiled like they are in C. I'll talk a little bit more about this on Monday. They're what they call scripts. So that means that the MATLAB interpreter opens up the script and executes one line at a time in the script. There are some languages such as Java is a script. You'll hear the term JavaScript. And JavaScript is a language that the web browser opens up your Java program and executes the Java one line at a time because each browser handles each command slightly different. Right there. So anything that deals with web browsers is almost always a script. That there. And MATLAB and Octave use M files that they're as scripts. So, but the assignment operator, we could use an assignment operator either in the command window or in a script right there. So again, when we type x is equal to x plus 2, now this is kind of an interesting one because that works the same in a computer program. That's there. X is equal to 3 is fine, but x is equal to x plus 2 doesn't make sense if you're in Dr. Aswana's course in algebra, because x can't be equal to x plus 2 unless x is equal to 0. Right there. I mean, it doesn't make any sense in algebra that there. But in programming languages, it does, because it takes whatever was in x, adds to it, and puts it back into x right there. So that there. In algebra, you can't write x plus 2, but that's there. Again, you cannot put any algebraic expression on the left side of the equal sign. It has to be a single variable. You can't put any constant on the left-hand side of that there. So whenever we have the assignment operator, the only thing you can have on the left side is something like an x, y, z, or whatever right there. So again, this goes back to that there. And the right side must be a computable value. Everything on the right side must be defined right there. So what that means is that I can't say z is equal to t plus s plus t, because s is defined. S is 500. It's already in the, but it doesn't know what to use for t. Now, as soon as I say t is equal to 200, right here, right there. And then I go back here and I say z is equal to that there. Now I can calculate it. It's not computable right there. So anything on the right side has to be defined at that point right there. I can't have any undefined variables that's there. So this doesn't necessarily say that. Now these are some commands right there. And here, and these are clear the command window, clear all variables, clear certain variables, determines whether or not a file or variable exists, having that variable name. I don't use that one very often, and quit. So those are some of that there. List the current variable, list the current the current list the current variables and the sizes, indicates if they have imaginary parts. And by the way, MATLAB does allow imaginary numbers right there. Colon generates an array, comma separates the elements, semicolon separates it there, and dot 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 more right there. So these are a number of the commands, and I'm just going to go through and probably spend, I don't know where we are on slides right here, but right there. But again, you know, oh, I didn't want to keep that there. Well, that's all right. But if I go into here, so for example, I can say who S. Your variables are S. Who. That tells me what variables I have. This tells me the size of them, how much memory they're taking right there. I can say exists T. And the answer is 1, which means true. I can come back here and say K, and K doesn't exist. Now, using the exist doesn't necessarily make sense here because I got the workspace right in front of me on the left-hand side. But if I'm writing a script, I might want to know whether or not those variables exist yet at that point right there. The colon, we've already talked about that. Oh, clear. If I do a clear, notice the workspace disappeared. Everything that was in the workspace is now gone. Right? And I could do a clear X, for example. There's no X there because I already cleared it right there. But if I go all the way back here, well, I'll just say X is equal to 1, 2, 3, 4, 5. Close that. And what is it with me and this equal sign today? The problem is that that's the affected hand. And I go up there and I think I hit it, and my finger doesn't hit it right there. So, that there, and y is equal to 3 times x right there. So y is an array that I multiply that there. And I can do a clear x. X disappears, so y stays in place right there. So again, these are all, that's there. CLC clears the command window. CLC right there. Now notice it doesn't clear the command history, and if I hit the up, actually if I hit the up button, it still works right there. It just clears the window right there. And I sometimes use, instead of CLC, I'll use CLS, because that's the old DOS command for doing the same thing. And I mentioned the word DOS a number of times. DOS is the original operating system of the x86 family of computers back before the days of Windows, right there. And I'm an old person. My first IBM PC that I bought, and it was made by IBM, it was that there. It was 3,000 USD that I bought in 1983 or something like that, 82. I can't remember when they first came out. It came with DOS 1.0 right there. And there was no Windows at that time, and everything was command window or command line driven. And for those of us that grew up, and when I say grew up, I was in my mid-20s at that point when I bought that computer. So I was not much older than you guys were up there. I think most of you are 20, 21, somewhere in that neighborhood, 19 in that area up there. So at that point, I learned how to use DOS commands, or commands from that's it. So I am very comfortable with the command window. A lot of younger people look at this command window, and these are very cryptic type commands, and they don't make sense to you. I grew up in the area that's what we used most of the time. Because before DOS, we had a program language called CPM, Computer Programming for Microcomputers, right there. And that was for 8085 and Z80 based computers before the 8086 came out. And that came out about the late 1970s. And it was very similar to DOS. Matter of fact, DOS was CPM, a version of CPM that Bill Gates bought from somebody and resold it to IBM. He modified it, him and Steve Wozniak, not Steve Wozniak, Paul Allen, I think was his programmer at that time. But the two of them developed the first version of DOS for the IBM PC and formed a small company called Microsoft. When I say a small company, it was very small then. It was two people in his basement, I believe. It might have been his bedroom he was operating in. Jobs worked out of a garage, so that's it. But regardless, these command windows commands are very, very common to us old people. You young people, they're very, very cryptic right there. So I'm comfortable with them. And a lot of MATLAB programmers, because MATLAB's command window is based on the old DOS type commands, and Linux has got a very similar command window. It's actually closer to the Linux command window than the DOS command window. But a lot of Linux developers and a lot of Linux system managers are very comfortable working from a command window. And Linux is an operating system that has been around for quite a while. It's a hybrid version of Unix. Unix is an operating system that was developed by AT&T or Bell Laboratories back in the 1970s. And probably 80% of all supercomputers or very large computer systems are running a version of Linux or Unix today. Most computers run Windows. Windows is designed for people who are not computer literate, as a general rule. And I use the word computer literate. They couldn't write a command script if they had to, and they couldn't do batch processing, and they couldn't set up device drivers and those kinds of things. I mean, and again, does your grandmother need to know how to do that stuff to use Facebook, right? As electrical engineers or engineers in general, you're expected